This video is checking the TPU principle from Akula, or some free energy developers say NMR principle, or I think the ferro resonance from some free energy developer is the same context. So what I am seeing from the Akula experiment is I am putting the input along this the Yoke core, and then I am seeing the output from this 90-degree coil. 90-degree coil. I am seeing the output. If it is normal physics, nothing should come out because this direction is where the magnetic flux is going on. So along the magnetic flux, no voltage has to be induced. However, it's really funny. I am putting the first square wave. The square wave is going on here, and this one is the yellow probe, just to check the current, how much current is consumed, which will be also important for this discussion. So I am putting the square wave, and from the 90-degree coil, the output is measured, which is nearly close to 1 volt. It's quite a lot. Quite a lot of voltage is measured. If I put the sine wave, now it's sine wave. If I put the sine wave, then disappears. So it has to be square wave, or if I put the square wave, that means actually the shock pulse is going. That's why we need to give a shock. That's why it's coming out. So normal sine wave wouldn't come out. Anyway, it's like that, and then if I increase the frequency, now is about 200 kilohertz, and then it's saying the 600, but it's not. Let me see. It says 600 actually. Let me see. Okay, another interesting thing is actually I am putting 200 square wave, and then the 400 is coming out, which is understandable. One is pulsing up, and then the other is pulsing down. So that's why it's a double frequency. It looks like a double frequency, but it will come down and then join. And then I am increasing the frequency now is nearly 1 megahertz. The reason why I'm watching the current input is I don't want to fall into the LC resonance, which the maximum current will be consumed. And then I keep increasing, then it's now the output becomes even bigger. Now the output pulse, now it's making the proper square wave at the high frequency. Its input is 2.8 megahertz, and then it's going up, up, up. Yeah, now the output resonance is increased. I didn't calculate. It's not LC resonance because the current is not changed. It's it's about the standing wave, about the length, I think. And from 3 megahertz, yes, it's quite big. And then I'm going over 4 megahertz. Then the waveform becomes again sharper. Yeah, and then the size decreasing. It's nearly the sine wave form now. The the output, which is now 5.3 megahertz. And uh, then I'm going to see what about the real pulse input. How I can make the pulse input is I can make a coaxial cable like that, and then the end is short circuited, and then the pulse is going is a coaxial cable. Because the coaxial cable and the other end is short circuited, the current input is increased a lot. Yeah, so which is reasonable, and then but the output is actually a little bit less. So the output has to be uh, stronger. Anyway, I am going down the frequency now. Yeah, current is consuming a lot because it's so the other end is short circuited. Yeah, this current, really a lot of current is consumed. It's the kind of the LC resonance area, 3.3 megahertz. Oh, it's even bigger. Anyway, the output is not increased, so the shock wave is not a good idea. I have to reduce this. Yeah. I'm going down the frequency is nearly 2 megahertz. So going down. So output is not greater. So I I think instead the the pulse is it's because one pulse, the pulse looks like just joining together. That's the only effect. So in this scheme, you don't need to do the coaxial cable, so to speak, nanopulse. This is enough. Square wave. Sine wave doesn't work, but square wave works. Then uh, the output is this, and then current is a lot less consuming. I'm increasing the current, uh, the resolution, and then let me go higher. And there is another interesting effect. Actually, the frequency doesn't matter, but I will go up and show. Yeah, around this area is the maximum output is coming. What I'm gonna do is I'm gonna short circuit the red probe and the ground. If I short circuit, then if it is the normal transformer, then the current will increase a lot because it wants to keep the voltage conversion ratio. But I'm gonna short circuit now. Yeah, it's the short circuited, but the current doesn't change at all. So this is actually extra output. It's not consuming the energy from the generator. I mean, it doesn't consume more if I put the more load. Short circuit means putting more load. So in this behavior, the I'm going down the frequency down, whatever. Okay, so around here is a 2.6. Again, if I put current doesn't change at all. Yellow probe is the current, input current. Current doesn't change, although I short circuit this. And then I'm going down. It's around 1 megahertz. Short circuit, but the current doesn't change. So if I put this input, then this output is always the same voltage, which is crazy. Always the same voltage, although I change the load. So that's a great finding. And then I'm grateful to Akua.